Hi there, this is Timothy Isaac Yin, and I'm continuing Oxford Dictionary of Electronics and Electrical Engineering Dictionary with letter A. Acoustic delay line. Delay line. Acoustic feedback. Unwanted feedback of the sound output of an audio frequency loudspeaker to a preceding part of a sound reproduction system via a microphone. The sound waves can be detected and amplified by the electronic circuits in the system. Above a critical level, oscillations are produced that are heard as an unpleasant and self-sustaining howling noise from the loudspeaker. Acoustic pressure waveform. The time variation of acoustic pressure, for example, is output from a pressure-sensitive microphone. Acoustic wave, sound wave. A longitudinal wave that is transmitted through a solid, liquid, or gaseous material as a result of the mechanical vibrations of the particles forming the material. The direction of motion of the particles is parallel to the direction of propagation of the wave, and the wave therefore consists of compressions and rarefactions of the material. The term sound wave is sometimes used specifically for those waves with a frequency falling within the audible range of the human ear, i.e., from about 20 to 20 kilohertz. Waves of frequency greater than about 20 kilohertz are ultrasonic waves. In a crystalline solid, an acoustic wave is transmitted as a result of the displacement of the lattice points about their mean position. The modes of propagation are constrained by the interatomic forces active between the lattice points. The wave is transmitted as an elastic wave through the crystal lattice. The angular frequency, omega, of the wave is related to the wave vector k by the relation m omega squared equals to 2 epsilon p greater than 0 cp 1 minus cosine p ka, where m is the mass of an atom, cp the force constant between planes of atoms separated by p, where p is an integer and a is the spacing between atomic planes. The range of physically realizable waves that can be transmitted is pi greater than Ka greater than negative pi. The limits of this range define the first Brillouin zone for the crystal lattice, and at these limits traveling waves cannot be propagated. Standing waves are formed. The energy of the lattice vibrations is quantized. The quantum of energy is the phonon, which is analogous to the photon of energy of an electromagnetic wave. The phonon energy is given by hv, where v is the frequency, and is equal to omega over 2 pi. A traveling acoustic wave is in a solid can be produced by applying mechanical stress to the crystal as a result of magnetostriction or of the piezoelectric effect. The resulting phonons can interact with mobile charge carriers present in the material. The interaction can be considered as an electric vector analogous to the electric vector associated with the electromagnetic wave that extends for about a quarter wavelength distance orthogonal to the direction of propagation of the wave. Acoustic wave device. A device used in a signal processing system in which acoustic waves are transmitted on a miniature substrate in order to perform a wide range of functions. Active and passive signal processing devices formed on a single semiconductor chip have been produced, including delay lines, attenuators, phase shifters, filters, amplifiers, oscillators, mixers, and limiters. Okay, we'll read up to this as much as we can today, and hope you guys have learned something and enjoyed the video. See you in the next one.